Hey Geometries, this is Mr. Bloom and this is Lesson 8.3, Trigonometry. Now our objectives, students will be able to use the sine, cosine, and tangent ratios to determine side lengths and angle measures in right triangles. Again, this is all about right triangles. Okay, so let's get moving on here. Okay, our essential understanding. If you know certain combinations of side lengths and angle measures of a right triangle, you can use ratios to find other side lengths and angle measures. And that's what we call solving a triangle. Any two right triangles that have a pair of congruent acute angles are similar by the angle-angle similarity postulate. Similar right triangles have equivalent ratios for their corresponding sides called trigonometric ratios. Now the ratios we're going to be working with are sine, cosine, and tangent. And we have a relationship here of what those ratios are. This is the name of the ratio, the sine ratio of angle A. So if I go over here and talk about angle A, its sine ratio is the length of the leg opposite angle A. So I have to know what opposite is to angle A. So this is opposite A. And the letter associated with opposite of the large angle letter is a small a. Letter associated with opposite of B is a small b, and associated with this capital C is a small c. So when we're looking at this, we're going opposite, hypotenuse, and that is the ratio for sine. The cosine of angle A is the length of leg adjacent to angle A. Now the adjacent leg is the leg that's not the hypotenuse. So angle A is here. This is the hypotenuse. So this is the side adjacent to angle A. Okay, so that's why we're able to say the adjacent side over the hypotenuse. And this is where we're getting our values. And these small letters, again, are numbers. They represent numbers, and that's our ratio. Sines, name of sine ratio is opposite over hypotenuse. The cosine ratio is adjacent over hypotenuse. Now we have a tangent ratio, which is the length of a leg opposite angle A, so angle A, opposite angle A, and the length of a leg adjacent to angle A, adjacent to angle A and B. Now, if we were to focus, if we are focusing on angle A, side length of A would be called the opposite side of the length. So that's what we're talking about. If we are focusing on angle A, side length B would be called the adjacent side length. If we are focusing on angle A, then side length C would be called the hypotenuse. Now please keep in mind, we're always going to be calling side length C the hypotenuse. Okay, so keep that going. The things that'll change based on the angle we're talking about is our opposite adjacent, and we'll get into those as we do more problems. Now, you can abbreviate the ratios at sine of A, the sine of an angle. Okay, now this represents a number. Okay, once they put together, they stay together. So the ratio, sine ratio of A, is the opposite over hypotenuse. And what this is, if I put the sine A into a calculator, sine of any angle, it has the same recall, or the same value, I should say, as the opposite side of that angle divided by the hypotenuse. The cosine of angle A, remember it's a cosine ratio, has the same value as the adjacent over hypotenuse. And the tangent of whatever angle A has the same value out of a calculator as the opposite over adjacent. Now, when you think about this, you got to keep in mind a couple things. I'm not sure if many of you know, I've been coaching swimming forever, so if you really get stuck, it's like, what did Mr. Bloom say? And it's what you do when you go swimming. And people are like, what do you mean? Okay, this is so, this is ka, and toa. This is sine, opposite over hypotenuse. This is cosine, adjacent over hypotenuse. And this is tangent, opposite over adjacent. So what do I do before I go swimming? I soka toa. I put a foot in the water and see if it's warm or cold. See if I got to get ready for it. Okay, so I soka toa. All right. So keep that in mind. And remember, it's the sine of angle A is opposite over hypotenuse. The cosine of angle A is adjacent over hypotenuse. And the tangent of angle A is opposite over adjacent. Now, please keep in mind, A is just the sine, cosine, tangent of any angle can be represented by these, okay? Now, let's write these trig functions. Let's practice. And this first one we're going to do, I'm going to reverse that. This first one we're going to do, we're talking about sine. So if I'm looking at sine, I've got the sine, and I want an angle t. So we're going to look at angle t, all right? And 8 is opposite angle t. 15 is adjacent. This is the adjacent side to angle t, and this is the hypotenuse. Not because of angle t, but because of this angle right here. That tells me this is the hypotenuse. So what I'd like you to do is, remember sine is opposite over hypotenuse. Cosine's adjacent over hypotenuse, and tangent's opposite over adjacent. So for angle t, please put in the fractions for these, and I'm going to put in the first one for sine. Sine, again, is opposite, so opposite angle t here is 8 over 17, because that's a hypotenuse. Please fill in the other two. Okay, so now we're looking at the other two, and when you're doing the cosine, you got 15 adjacent over hypotenuse. So it's 15 over hypotenuse. Okay, and then if I'm looking at the tangent, it's opposite over adjacent. So we're looking at 8 over 15. Now, it's your turn, and we're switching angles. So now our focus will be on angle G. Now, with this focus, 17 is still the hypotenuse, but from G, our opposite is 15, and from G, our adjacent is 8. So now, as we write our ratios, we are going to have those change. So you guys turn me off and write the 3 ratios from focusing on angle G. Okay, you turn me back on, and we got that going on. So we're looking at angle G, and I've got opposite over hypotenuse. And from angle G, I have adjacent over hypotenuse. And from angle G, I have opposite over adjacent. Okay, so those are our ratios for sine, cosine, and tangent for angles T and angle G. And remember, that was us focusing on that angle, and we always had the hypotenuse stayed the same. Now, we're going to use a calculator to find the ratios. It must be in degree mode, so round to the 4th digit. And we want you to round to the 4th digit after the decimal. So now, with this said, this is another way of looking at ratios. Remember, what we just did was the ratio of some unknown angle was, for sine, was opposite over hypotenuse. Well, sine of 30, if I have a 30-degree angle in a right triangle, I'm able to find out what that sine is. And we're going to talk about that in a second. But for our calculator functionality, we're going to look at sine, cosine, and tangent. Now, it's really cool that sine, cosine, and tangent, I've just got to get a pointer here. Sorry, guys. So we're going to look at sine, cosine, and tangent. And when I'm looking at this, I got sine, cosine, and tangent, and they're all 3 in a row. So sine, cosine, tangent. So it's really nice to think about SOHCAHTOA if you just look at your calculator buttons, and they're all in the same order. There are some calculators that just have a trig key that you need to go second trig and be able to push on it, and it'll be pushed in that order. But in these, I've got the inverse sine, inverse cosine, inverse tangent up there, and everything will be great. So now let's see how we use this. So I'm going to put in the sine of 60. Now I got to close my parenthesis, the sine of 30. So I've got to close my parenthesis and I hit enter. Now, the sine of 30 comes up as negative 0.988031. I know that's wrong. I know that's in radians. Okay. So when I'm doing this, I've got to make sure I check this out and find out why that is the case. So I'm going to hit this key. I'm going to hit my mode key, and TI-84 is in the mode. And I'm looking at this idea of radian. This is radian. Radian is another measure of angles, but we are interested in having it in degree mode. So we need to put it in degree mode, and I'm going to put that down and put it to the right. And now it's in degree mode. So now I can go second quit, and I can recall the same entry and hit enter, and now it's 0.5. Now when I round to the nearest, the fourth digit, and I've got 0.5 in my calculator, I've got 0.5, and I pad it out with 3 zeros, and that is rounded to the fourth digit. Now, we're going to do the rest of them the same way. I've got the cosine of 60. Okay, now that my calculator is in the same, I'm starting to wonder what the deal is here. Boy, are all of them going to be the same value? Okay, I got the tangent of 45. Okay, so I've got the tangent of 45, and that's 1. Okay, so when we're back here, and I got 1.0000, rounded to the fourth digit. And I got the cosine of 89. Cosine of 89. And that's 0.0175. 0.0175. Now, it was 74, but I'm just going to move this over so you can see that what I rounded to. See, I've got the fourth digit, 1, 2, 3, fourth digit. Okay, so I've got the fourth digit. 5 is bigger. If it's 5 or more, then I round this one up. So that's what I did. So now I do the sine of 89, and I can go second, enter, and just change my trig function and make it sine of 89. And I've got 0.99984. So my fourth digit is an 8, but my fifth digit's a 4, so I will leave it as 8. So now I go 0.1238, and those are my values. Those are my ratios of angles, okay, when I'm looking these over. Now, what's really interesting is we have already worked on a triangle that was a 30, 60, 90. And if I had a 2 here, that would be a 1, and this would be the square root of 3. And if you start looking at this, you go, oh, yeah, that's that 30, 60, 90 triangle, but where are the x's? Well, see, this is the ratio that exists, and if the x's were there, they'd be right here. Okay, but now, I'm not going to worry about those x's right now. Okay, what I want you to realize when we're doing this is the fact that this ratio exists. So if I'm on the sine of 30, if I'm here at 30 degrees, that's opposite over hypotenuse, that's 1 over 2. Hey, that's 1/2. If I'm on the cosine of 60, that's adjacent hypotenuse, and that is also 1/2. So when we have triangles and we look at these ratios, we are always going to have returned to the ratio value of 0.5 for these two values all the time. Okay, so keeping that in mind, we're going to move on to our next thing. Now, find the value of W to the nearest tenth. Just going to make sure I didn't miss anything. Now, we can use this ratio just like we did in Chapter 7. So if I'm standing with my focus on 54, this is a right triangle, okay? I have the hypotenuse, and I'm looking for side length W. Now, I use this when I don't have two sides, because if I'm looking for sides and I got two sides, I'm going to pull out the Pythagorean theorem. But I'm looking at 54, and W is opposite the 54, and 17 is the hypotenuse. So I've got sine, because I'm going to use opposite hypotenuse, that is sine. Remember, so, ka, toa. It's what I do before I go swimming. Okay, so sine of 54 is equal to opposite over hypotenuse. Now remember, this is a number. We just found that out. Sine 54 stays together. Now 17 as I'm looking that over, I'm going to go, well, gee, I can multiply by 17 and just solve for W. So I'm going to multiply both sides by 17. So I've got 17 sine of 54 is equal to W. I plug that into my calculator in that order. So I'm going to go 17 sine of 54. Close my parenthesis. Hit enter, and I get 13.75. Now, they asked me to round here to the nearest tenth. So I get, on my calculator, 13.75. So I have 13.753, and oops, they asked me to go to the nearest tenth, so we're going to go 13.8. 13.8 units is W, and that is the length of W. Now, remember what I did. I stood on the angle I was given, I looked across, and that's opposite. And this is hypotenuse, so that's why I chose sine, opposite hypotenuse. Now, your turn. Give it a try. It's going to be one of those three trig functions, sine, cosine, tangent. Stand on the angle we got and decide which one you use. And by the way, part of this is you identifying where the hypotenuse is located. Okay, turn it off and try it. All right, welcome back. Now here's the thing. I'm going to identify the hypotenuse. So I'm going to start out with black here. I'm going to stand on the angle at 28. And this is my right angle, so this is the hypotenuse. I don't have a value there. So I shoot across, and that's opposite, and this is adjacent. So opposite adjacent is a tangent because it's TOA. Tangent of 28 is equal to the opposite over adjacent. So now I multiply by W. Now this one's tougher because I did opposite adjacent. This one's tough. I'm going to multiply by W, and I've got some folks going, really? You're multiplying by W? I got to get W on the main line. So now W, tangent of 28, is equal to 1. Now, to get rid of the tangent of 28. Remember, this is a number. The whole thing stays together. The tangent of 28 represents a value. And so I'm going to divide by tangent of 28. So now I get W is equal to 1 over tangent of 28. Now there's a couple ways I can put that in my calculator, but I've got 1 divided by my tangent of 28. And that's the first way. I could go, well, tangent of 28, and I could flip it, okay, and hit enter, and it's the same value. So it's 1.88, and I'm supposed to go to the nearest tenth, so it's 1.9. So this is 1.9. So I got my W here for B and my W there for A, and make sure you're careful of how you set it up. It's all about sine, cosine, and tangent. And I remember people would say, well, it's not rocket science. This is rocket science. This is the type of stuff they use to help you figure out stuff. So keep that in mind. It's fun, it's exciting, and I'm always thinking about what I'm doing before I go swimming. So, SOHCAHTOA, it's your turn again. Stand on the angle. Decide where the hypotenuse is located. Hypotenuse is there. Hypotenuse. Oh, I got a hypotenuse. What's W to the angle? Is it opposite or adjacent? Because I already know the hypotenuse. Okay. Opposite is over here, so this must be adjacent. So adjacent hypotenuse. Adjacent hypotenuse is cosine. So I have the cosine of 33 is equal to the adjacent over the hypotenuse. Okay, that's my setup. Now I just multiply by 4.5 on both sides. So I got 4.5 cosine of 33 is equal to W. to find my W value, I must have a calculator. By the way, if you're not carrying a calculator every day, because I do not have enough for everybody, or the other teachers don't, you should start, because you can't do this stuff without a calculator, and having that "I didn't have a calculator" as an excuse is not an excuse, okay? So you must have a calculator that does this. All right, so I've got this going on, 4.5 cosine of 33. Hit enter. So this is 3.8, okay, as I round to the nearest tenth. 3.8 is my value for W. Now, let's slide on and see what else we have in store in our notes. Look, it's our assignment. We get to start our assignment. So make sure you go over the information, and if you have any questions, you must seek out enlightenment and talk to one of your local geometry teachers. But remember, what do you do before you go swimming? You soak a TOA. And this should be at the top of every one of your pages to help with ratios. Well, I hope things go well. And again, if you have questions, ask them. I'm Mr. Bloom, and you're not. Have a great day.